So this is the model that we're going to make.
Whoa.
Which is it's just a massage roller. So
Sick.
your handle and your little wheels down the bottom. So I won't go through modeling in this video, but we'll just go straight to the cam. So basically in Fusion 360 you have these tabs down the side so you can design your parts, render them so you can create photorealistic renders, animation, so exploded views, how stuff goes together, simulation, so you can do like forces and work out whether the parts are strong enough. Then manufacturing. So manufacturing is where you generate all the tool paths for CNC. So that's the bit we're going to do mainly. And then drawing. So drawing is where you take the parts, you lay them out, and you put them on a traditional sort of 2D drawing. So in this case, we're going to switch straight over to manufacture. So first up, we'll delete these setups because that's what we're going to create in this session, so pretend that doesn't exist. You want to create a new setup here. Stock. So basically you want to pick, just for this you want to pick no additional stock. Setup, just while Courtney's fixing that. Pick the parts of the model that you want to include, and you can see the stock's adjusted to suit that.
So by stock you mean like wood?
Yeah, the wood piece, or it could be plastic or steel or whatever. In the case of our machine, it's only really meant for timber, but you could probably do foam and lights. You can do aluminium, but typically timber is what we'll be doing, and that's what I'll be teaching because I'm not very good at doing anything else. So an important sort of rule with this is that you have to set the coordinates of the job. So where 0 is on this piece of material, that's up to you to choose. So you could make the top is 0 and the bottom is like -20, for example, or the bottom is 0 and the top is 20.
You're talking, so like a piece of this wood, imagine if you were going to be cutting this,
Yep.
then you could say this is 0, this is 100, and then this is -20 there.
Yep.
Or you can start on the bottom, so
And
that's
go
0
up.
there, this is 20 here, and this is
Yep.
100, 100, 20.
So yes, exactly. So basically, it all works on coordinates, like it's a coordinate system. So you can pick if the coordinate system starts here, or it starts here, or it starts there, or whatever, right? So it's completely up to you, but you should do it the way I tell you, because that's going to greatly improve the chance of getting it right. Okay. You don't have to follow this, but if you don't, it's your probability of crashing or destroying your timber goes up a lot higher. So you really need to know what you're doing if you're going to deviate. Basically, what we want to do is make sure that the piece, the rectangle.
This is the thing that you're referring to with your
The
hand
stock.
right here. This little diagram, this XYZ thing.
Yeah. That's my hand. So the stock. That should all be in positive X, Y, and Z. So what do I mean by that? I mean that, and this tool for picking the orientation is not very intuitive, so you might need a bit of practice, but the way I do it is go select Z axis, and then you pick an X direction, so you could say that I want that to be my X, which I know is really funny, and yeah, I know you're lost. You probably just have to play with it. So basically what I want to do is make X that direction, Y into the page, and Z up.
And you do that by, so if you measure on this, it says select your X, and you'd be like, something on this plane is X, something on this plane is Y, something on that plane is Z, and then it figures it out, so then it knows how to tell the
orient
tool
itself.
to move.
And then if it gets it wrong, you can flip. So that's how. But
X
like,
and Y don't matter that much, right? Unless it's
as long as it's in the positive. So we could pick this point, or we could flip around to that point. It doesn't really matter. But you can see here that we've got in the X direction, the material is in the positive X direction, the material is in the positive Y direction, and the material is in the positive Z direction.
What does it look like if it's not?
So what would it look like? Like that?
Ah.
Or like
I
that?
see. Right. The arrows are pointing.
That's the most worst.
Yeah.
So basically you want the arrows pointing into the material, right? But that tool is really quite, like I've kind of got my head around it now, but it took me, like I was like, I remember when I started learning this, so in this case, it's not working for me, I'm not getting it, it's not working right for me, so I'm just going to, I can't get it to flip the right way, so that's now my new origin. But you can see we still have positive X, Y, Z. He's an old hand, so.
I'll sit over there. I have good vision.
Yeah, I can see all the big stuff, but not the little stuff.
Yeah, sit right up close.
That's right.
I also.
So the material level, he also kind of knows what he's doing, so he's just getting that fresh.
I'm asking the question.
He's asking good questions.
I'm asking the question.
Like we'll find a piece of timber, and it'll probably he's doing it to try and make a bit extra.
Oh yeah.
So this we're just telling the machine. This is what you're working with, but in reality, it'll be bigger. But it'll just deal with it. So if you're doing like really precision engineering, you'd actually make sure that your stock is. So possibly he can sort of.
No, you have a lot of assumed knowledge.
I have a lot of assumed knowledge. Exactly.
Has a certain level of knowledge.
Wow. So now we've got like our model and our stock and our orientation in space. Now what we need to do is add operations. So an operation is any sort of pass of a tool. So one operation is drilling, like you drill holes, right? Another operation is what's called facing. So that's where you just pass a mill over the top of the material. So that just makes everything flat. Another one is pocketing. That's where you create a little recess into the material. So I'll go through these, and hopefully it'll make a bit more sense. Another one is called profiling. So profiling is, another way to say profiling is cutting out.
You might have a sample piece with all of those.
So if you have, if you would pass me that so this is,
Oh yeah.
so
He's one step ahead.
there's a micropen earlier. Oh, I glued that in, so that's why that doesn't come out. So in this case, if you want to pass me those two other pieces there. There's little.
Yeah.
Show it to the camera as well. So these two pieces came inside, were cut out from inside. So that's how try and make use of the material, right? So an example of this. Okay, so the first thing we did with this is drill these holes. Okay, we drilled those holes. Then what we did is we went and pocketed in here. So that's a pocket. So that means like removing material but not going all the way through. Last thing we did was profile. Oh, sorry, there's a pocket in here that's obviously got this bit in it as well now. The last thing is to profile. So we profile in here and then profiled around the outside. Okay?
Did you do all of the operations of the same type in the same?
Yes.
So the 3 drills were all one operation?
Yeah,
and the
so
2 pockets
drills are
were one
operation. The pocketing, so that and that were done together. The profiling, you want to order it, but that's okay. They can be done together, but basically you want to cut inside then outside. And what's the reason for that? Basically, as you start cutting stuff out, you're weakening the piece of timber, right? The piece of timber is held there in place with screws or whatever. And as you start removing stuff, it starts to want to move around. So basically you want to do the least intrusive operation down to the most intrusive. So the first thing you do is do the drill holes because it doesn't really disturb things too much. The pockets don't disturb things too much, but profiling does, so that comes last, typically.
And also your little bits in the middle, you want to do those first.
Yes, you want to
do. Want to fly out.
So when you cut out these guys, they want to pop out. So if you've cut out the outside, this whole thing can rotate, and then you've kind of lost your positioning. So basically, you're going from most likely to move to least likely to move, or fall out of position. Okay. Great. We've done, we do, like, I make sort of shapes like this, like out of 18mm plywood with you know, the same sorts of operations all the time. So I have a set of saved operations. So these are operations August 19, which will fire in. And you can see there's a series of sort of operations down the left here. So these are using different tools, and you can see on the simulation that's what the tool head would look like. You can see that the head changes as you go down the simulation path. So there's a 4mm cutter and there's a 6mm cutter. So different tools. So to start, we don't need that guy, so we'll just delete him. I'm not going to use him.
Cylinder, or is that like a whole tool?
And that's the motor.
So the big cylinder is just to show the vacuum and the motor head. Yeah. So basically, it'll do crash detection. So if you're trying to cut something and that circle hits something, it'll show a warning. So yeah, you shouldn't be going if you went really deep, and it caused it to crash. It would tell you that. So don't do that. So we can delete that one. We're not going to use that one. We're not going to use that one either. And we're not going to use this one. Well, we might. We'll use that one. That's fine. So first thing we're going to do is we're going to drill some holes. So you can see that, I don't know, that's pretty small, but that's that symbol, the drill symbol here. So that's what that is. Anyway, so we've got the tool. So it's a very tabular sort of process. You've got the tool, geometry, heights, cycle across the top. So we'll start with tool, obviously. We can select a different tool. Currently we've got a 3.8mm flat end mill, but we want to change that to probably I think we want a 6mm drill.
Is your hole 6mm?
Yeah, the holes are 6. So the holes are 6mm, so we'll use a 6mm drill. Then you can see here that the tool number is 26, and that's a 6mm drill.
And you have a set of tools down next to the machine that are like numbered, sort of.
More or less.
Yeah.
So most of the tools that are in the tool library here, not that tool library, but this tool library, correspond to something on the board, downstairs in the thing. But it does take a bit of familiarity. So you can see the spindle speed is 8,000 revs. The surface speed is this. Plunge feed rate is 800mm. So that's how quick it's going to go down. 800mm per minute. Yeah. And then there's a few other bits and pieces. And
Are these all default or?
so these are set, but there's not too much science to it, to be honest.
If you were going to be cutting aluminium, that would all be different.
Oh,
Yes.
okay.
Or a harder or a
soft.
softer thing.
Yeah.
But because we generally only cut 18mm plywood, it's pretty pretty.
So yeah, and even I would say that's right. So we just use these we just use these values all for everything because we're using the same material, but also we don't know better. So I mean, there is some more research to do to actually put better numbers in, but they're working, and
So we stick with that.
we stick with it. But I mean, it is something that needs more research because there's definitely science to it. So now we're into the geometry. So we can pick hole mode. So we can do a points or a diameter range or faces. So I'll just unselect it so I can select it again. You can see that I hover over the geometry there, and it's finding that cylinder. And now it's created a tool path. So there's a drop into each of those, and then we'll get that one as well. So now we've got all those 6 holes. The good thing about it is if you have that selected, select same diameter, it'll automatically pick all the holes of the same size. So
if you hover over any tool in the UI, like you just did,
Which one?
hover over there.
Oh yeah.
It shows a really cool little description with pictures.
Yeah. So that's a good point actually. Yeah. So anything in this that you don't know what it means, you can just hold it here and it'll give you a bit of an explanation. So there's heaps of settings, heaps and heaps of settings, and there's a lot to it. Like I'm not an expert. I mean, I'm reasonably an expert, but I don't know everything. So I can be taught something by everybody. This is the one, this is called the heights tab. So it comes up with a bit of a graphic of what it considers the heights. So you can see here we've got a few features to notice. You've got the ball, that layer, is that blue? I'm colourblind.
Yeah.
But that's the stock top, right? Then you've got what's called retract. So the tool will retract to that height after it's finished. And it's also the same as the feed. In this case, it's also the same as the feed layer. So the tool will jog over to it, and then whatever the feed rate you said, remember how we said that plunge rate of 800 millimeters per minute? That's when it will start to do that. Okay, so it's sort of assuming that it's actually going into material from that point, just to be safe. So you don't like go really quickly into the material and then start cutting. It starts cutting a little bit higher just to make sure. Then you've got the
and it starts from the seed level or from the retract level?
So it's sorry?
I mean, you have that at the same height now, but
It'll start from the feed, but as it comes out, it'll retract to the retract height.
Okay.
And then it'll go back. So when you're doing a drill, it goes. What we're going to do is called peck drilling. So it drills a little bit in and then comes out. So when you're drilling something, you shouldn't just keep drilling the whole way through. You should drill, pull out, drill, pull out, and then what that does is it helps clear out all the material and keeps the drill cool. Because actually, if you heat tools up, if you heat them up too much, they soften and they go really blunt quickly. So temperature control is actually quite important. So basically what this will do is it will retract above the board and then plunge back in. Whoops. And so this is the clearance layer. So that's before it moves to the next operation, it'll go to that height. So it's really safe. So it's away from any clamps or anything you're using to hold down the piece. Okay? And then you can see on the bottom, you've got a bit of a hidden body, which is the tool, and you can see that it's got the same shape as the drill head, but it's going all the way through. So that's called breakthrough. So if you drill into a board, if you drill into the material, but you don't go through it, you'll end up with the hole not quite getting through, and you end up with a bit of a messy. It'll be messy on the reverse edge, so you actually want to punch through it into the table, just a little bit. Just a little bit. So you can set that here. So we do want breakthrough, and we want that breakthrough to be 1.5, but we could bring that down or up, and you can see it's dynamically adjusting. Okay, that's pretty much it. You got some other things with your pecking, and you see the peck depth is 4 millimeters, so it goes 4 mil, 4 mil, 4 mil, 4 mil down to the bottom. Okay, easy. We've done our first operation. Now we can come back and simulate it. So we're going to simulate, and so you can see that's the peck. See how it's coming up to the retract each time? Exciting, right? Now we can speed that up, and we can also skip to the next operation. Okay.
So what's this drilling, right?
So you can see. Yeah.
Oh yeah.
You can change some of the visual parameters so you can sort of get an idea of what it's going to look like and everything like that. Okay, cool. Next one. So there's a thing here called screw down, which is just basically passing an M code, like a macro, so to the CNC machine. So it should be that when it does this operation, the machine moves out the way and allows you to screw your piece of material into the board. But we'll skip that. That's sort of an aside. We'll leave that as a placeholder. We'll have a discussion about that later. Next, we're going to do the pocket. So this time we've got a 6mm end mill. Different cutting speeds and feeds. I won't go into it. But basically what we want to do is pick all the pockets. So what's a pocket in this case? A pocket is that one. A pocket is that edge inside and that edge inside. So what that's doing is hiding the bolt head. Okay, we press OK. You can see it's generating, and we can simulate.
that making the hole bigger?
Yeah. So it's when you put this thing together, you're going to put a little bolt in it, and so you want the bolt head to be just flush with the wood. So you've got to make embedded into the thing. So that's where the handle is.
And the frame.
That's exciting. So that's that's what I prepared earlier. Passed around the class.
So this was the first folding thing, and this is the.
It's the inside. So there's one.
So a nut will go.
It goes like this.
Okay.
So the way this goes together will be.
Oh yeah, the nut you tie.
So yeah, sorry. So then.
Oh yeah.
Lovely massage. Alright, cool. So we'll fill that out, and then what we would do is put screws in each of those holes. So to hold down all parts onto the table.
So when you're doing those pocketing or drilling, you're not really putting much pressure on the wood's just sitting on the table and it's not really moving. There's not really pressure on it.
Yeah.
And when you start doing those cuts, it's actually kind of
really
putting sideways
lines
on the board.
Yeah.
So yeah.
So
You want to screw it down at this point.
I'm gonna do a bit of a dirty trick here, but I won't go into it. But anyway, okay, so now we're going to do the last operation, which is called contouring or profiling. Yeah. What's the technical term? 2D contour. Okay, so again, if you hover over stuff, it tells you what it is. So in this case, what we're picking is the main part, so the final operations. So you can see, in this case, that's everything. This little red arrow just tells it what side of the line to cut on, so if you pick that one, it'll actually cut inside, which we don't want. But yeah, just be aware of that. And then I press OK.
One of them was on the inside.
Sorry?
That was good. Simulated.
So you can see that everything's cut out. I'm cutting out. So I'll flick one onto the inside just to show what that would look like. So you can see that in the case of this wheel, it's picked the path on the inside of the contour.
So
Right.
you get spiky roll.
So you get a spiky roller, which you don't want. Which no one wants.
Oh, inside.
Or
inside.
doing
Oh,
it, do
okay.
you?
Is there a video of this?
Sorry?
A simulation of how this is done?
Yeah, we'll do that. So so that's it basically. Well, that's the main thing. The other thing to add, the only thing more to add to this is that apart from screwing it down, we probably want to add what's called tabs. So tabs are a little bit of material that's left just at the end to try and hold everything in place. So I'll show you that now. So this is in here, this tabs item, and in this case we're going to pick at points. So basically you go around and select where you want to put a tab. So you can see that.
Does it show if you hover over the tabs thing?
Yeah.
The checkbox.
What a tab is. Yeah, so yeah, there you go.
Oh, just a little bit.
So so in this case it actually also simulates in the piece. So you
Is
can
that new?
That's so handy. I've never seen that before.
Is that new?
I don't know, it's been doing it for quite a while like that.
And you just break it off?
Yeah.
Oh, okay.
You can, but you got to be careful with that because you'll end up with a bit of tear out. See that?
Yeah.
So that's from the tab. But like I build it when I do this. I build it in a hurry, so like I'm usually not too careful. But if you're doing something you really want to finish nicely, you want to spend a bit of time and do it very neatly. So these tabs can break, obviously. If you're using plywood, plywood's only really strong if you've got both directions.
Yeah.
So you wanna get at least 2 plies, even more, because you're still when you're going over the tab, you still have to deal with all these twisting forces. So they still have to be beefy enough to sort of stand up to that.
So you're saying it to be more thinner or it should be
Thicker.
more?
Yeah.
Okay.
So you want to do probably 3 plies is a good I think would, like, intuitively is a good amount.
Because as you finish cutting the piece out, there's your wood and there's your piece, and you're like woo, around here. As you get to that last bit, it does that, except 1,000 times faster, and it's amazing. 95% of the time, it comes straight for your face. It's quite incredible.
Or worse, it'll damage the piece.
Yes. It gets caught in there, and then it's still drilling because it's a dumb machine with no camera on it, and it'll just keep drilling, and then you've just wasted an hour.
So especially when we're doing something that's a circle, the other thing that's important to keep in mind is that if you put a drill in there, like a screw in there, sorry, to hold it still, it's actually in the center of the axis of rotation. So as you're cutting it out, it'll rotate and unscrew itself and fly out. Do you know what I mean? So when you're screwing stuff down, you want to try and minimize that and have your screws like really offset. So if we put 2 screws on that piece, it ain't going anywhere. So that should be fine.
Okay.
But you might still add tabs so the rest of the waste material doesn't start moving around. Okay, so I'd be conservative with tabs when you're starting until you've sort of got a bit of confidence. The other thing that I would mention is so let's
conservative is
Conservative.
More tabs.
Yeah. More tabs.
But
I
remember
thought
that
too.
each tab you're gonna have to cut it, saw it, and sand it and file it.
So
it's more work for you, but it's also there is a balance. You'll find what the balance is through experience.
You'll find the balance through experience. Exactly. Very well said. So let's run this, and then we could maybe see what other problems are possible. So I'm going to run this really quickly. So you can see it's actually doing quite a nice little pattern here. It's sort of doing a little bit of a cut on one part, and then going to the next part, and then going back, and which is good because the alternative is obviously that it completely cuts out one piece and then cuts out another piece, and that's not really a good strategy. So any ideas of what could be a problem here? Just looking at it.
It's not going the whole way through.
No, it is.
The whole piece gets loose.
Oh, maybe not.
There's a piece in the middle.
I think that's just a rendering thing. Yeah, the piece in the middle. Well done. So these two. Who said that first? Was it you?
I think that's what he meant.
No, that's not what I
Yeah, you should have tabs for that as well. Or?
So we have a tab here and a tab here, currently. So maybe one here to keep it all together, and then this in the middle is very likely to fly out. So it's thinking about your parts, but also thinking about your not parts. Also, how a thing is going to behave. Okay. Cool. Dig it?
Yeah, it's just interesting how the tool goes outside of the stock.
It does because and that's fine.
Yeah.
In this case, I just misjudged it slightly. But basically, if the tools goes right down, if that blue line goes right down the stock, you've judged it really well. The other thing would be to think about if you do, the piece of stock that we use is likely to be quite a lot bigger than this because it's not that scientific. We get a big piece and we go, yeah, that'll work. Put it down and make sure it fits. But if you have a piece of stock and you put a cut across it, and it actually does cut it in half. Now those two pieces of the stock are independent, and now they can move. So restraint. A lot of this is about thinking about how to hold stuff down.
It will also warp a little bit.
Yeah.
So you want to make sure you have spaces to put screws in all over the place. It keeps it perfectly flat.
Yeah. So I'd say that's very true with thick stuff like this. Usually stays pretty flat. You can put a couple of screws in, it'll stay pretty flat. I cut out a table. Didn't need to put screws because the table top is so big and so heavy, it's just not going to move.
Oh, so
It's just its own weight. But if something like this is really, it wants to fly.
So you're using the free scrap that we have, it's sometimes it's been leaning against a wall.
Exactly. So thinner ply will have a bit of bow in it. When Dominic was doing his boat, basically he puts a screw in here, and because the material's so thin and flexible, the whole it bends really. like around it. You know, the part that he puts a screw in goes really hard to the board, but everything else wants to lift. It just automatically bows. So you end up with quality problems there.
So we fix the whole thing, you see? With this,
Yeah, but you need to measure it against, like, you need to sort of understand your material and how it's going to behave.
You also have to be careful, like, you want to use this to drill the holes and pause first. Otherwise, you'll just be like, oh yeah, put some screws in, and then you end up cutting through the screws and destroying the tool.
You'll hit,
So
yeah. Plan very much planning where your screws go and your how you're holding it down is at this stage, not later. So once you're happy, you can put the post process. Pretend we made those fixes. So we've got a post processor here. I'll just call it number 4 and put today's date. I did the same thing on the weekend. So this is the B footage.
So would it be wise to drill holes for your screws, to have them marked and to kind of have them in the mat?
So that is what we're going to do.
Oh, okay.
Essentially, I mean we yeah.
Yes.
Yes.
Yeah, so you can fake your thing and just screw it down yourself around the edges, and then lay this out, set your 0, and then not. But it's easier to actually put your hold down.
Yeah, I was thinking it's like the shapes
the
are
first
complicated,
stage.
and then
Just as the first stage, just like zip, 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 zip. Put your screws in, and then if it screws up, you just delete that stage from the processes.
Yep.
And because you've already got your screws in the holes, and then you skip to the second stage and
just keep the machine going.
Keep the machine going. Yeah.
So like, you know, one learning there would be that we actually do that little diamond piece and that little triangle piece, instead of trying to tab it, just make sure that those have got screws, so they're not going to go anywhere. So one more thing, this is a bit of a bug. You have to delete this line out of the G code. I'm really sorry. It's just this is called tool height compensation. So basically, most machines, the way they tell like where the end of the tool is they know where the spindle is, the drill, the thing that turns. They know where the head of that is, and then they add the length of the tool. Right? In our case, we don't do that. What we do is we pick up a tool and then we touch a little piece of we make a little electrical circuit, and that's how we tell what 0 is. So we don't use this coding. So basically what this is saying is compensate for the tool is 33.2 millimeters. So whatever your idea of 0 is, we've just added 33.2 to the end. So we don't do that, just the way the machine's configured. So we cut that out. I know it sucks.
And is it just this machine you're talking about?
Yes, so every machine has its own particularities. So that's, G43. So any line with G43 we want to kill.
Wow.
But there is a fix coming. It did used to work, but something changed with the Python code, and now you have to do this manually. But it's just temporarily. Okay.
There's always one or two things, right? There's always something.
It's always something
that's
not quite working right.
Yeah,
that's true. But we
it's just experience that teaches you which, like, you know.
Always try and work on it.
Yeah.
So I'll just go through the G code quickly. So you can see you've got the program name, and it's in brackets, which means G code is good question.
It's the language that it's an archaic industrial language.
Yep.
That consists of like an instruction and some numbers.
Yep.
So it might be like move left 40 centimeters, or lift tool, or set the speed of the motor, or do a thing this much, and each line is that. So some people like can just read it and be like, oh yeah, G21, that means go home. G28 with the tool.
So if you look at the 3D printer, if you look at the serial output on when a 3D printer is running, it actually writes this code. So a lot of machinery, a lot of industrial machinery still uses this. It's really old and terrible, but a lot of stuff runs on it. So like a G is basically like a command, and X is X coordinate, Y is a Y coordinate, Z is a Z coordinate, F is a feed rate, so that's how fast you want to go. T is a tool, so you can see we've got T162, so load tool 162. S is a speed, so set the spindle speed to 12,000 in this case, RPM. M3 is rotate clockwise. So an M code is a macro, what they call a macro. So it's a subroutine. So like an M code will probably have a lot of code behind it, which might be turn on this, turn on that, move there. So it could have a lot of stuff. So you can write your own M codes and insert them. And I think you might. So there's an example of a feed rate, and then you've got an I and a J here, which is an arc. So I and J is setting relative coordinates to do an arc. It's very complicated. You don't need to know it. All you need to know is that that's it. Usually after the interface, there's like a thing that tells you, so you can look up what the codes mean. And I still have to look up codes.
Not organisation.
It is. So what we want to do is we send that to MechMate74. MechMate74@gmail.com, and that was an output of the other program.
Then you have to take that file and then give it to the CNC, and it loads
Cool.
that file.
That's it.
USB drive.
That's it for today. Tune in next week. Huh?